The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, eventually today we're going to go on and take a look at section 4.3, but first we're going to visit some questions left over from 4.2. 4.2, you'll recall, is the substitution method of solving a system of two linear equations. All right, so this is from section 4.2, and this is number 7. It says, solve the system by substitution if possible. If the system has no solution or infinitely many solutions, so state. If there is no solution, enter no solution. And if there are infinitely many solutions, enter infinitely many. Okay, so we have two equations. The first equation is 5s plus 10t equals 9. The second equation is 2s plus t equals 0. I'm going to label these equations number 1 and 2 just for reference. So the first step in substitution is to take one of the original equations and solve it for a single variable. I'm going to take equation 2, which is 2s plus t equals 0. I'm going to subtract 2s from both sides of the equation so that I have t equals negative 2s. Let's see, I'll write that s a little better. T equals negative 2s. So I've solved one of the equations for one of the unknowns. The next step, I'm going to take the results, the fact that t equals negative 2s, and I'm going to replace t in the other original equation. It's important that I put it in the other equation, not back in the first equation that I used to solve for it, or it'll give me wrong conclusions. Okay, so put it into the other equation. Now I have 5s plus 10 times the quantity, negative 2s, because I replaced t with negative 2s, equals 9. If I've done this step correctly, this should produce one equation with one unknown. And I see that the only variable is s. Okay. Step 3 is to solve this equation for the unknown. So let's see, we've got 5s plus what? Negative 20s equals 9. So negative 15s equals 9. Divide both sides by negative 15. S equals negative 3/5. All right. Now, at the end of step 3, where I solved the one equation with one unknown, the results tell me what kind of solution I'm going to get. If I get a variable equal a number, like I did here, that means I'm going to get a single solution and I'm going to complete the ordered pair. If I get a number equals the same number at this point, that would mean that there are infinitely many solutions and it's the same line. If I get a number equals a different number, which is not a true statement, that would tell me that there is no solution. So I see here at the end of step 3, I have a single ordered pair. I know that s is negative 3/5. So now I have to solve for t. So step number 4, take the result, the s equals negative 3/5, plug it back into either of the original equations. I'm going to put it into the top equation. All right. So I get 5s, but s is negative 3/5, plus 10t equals 9. The 5's reduce down, and I have negative 3 plus 10t equals 9. I'm going to add 3 to both sides of the equation. 10t equals 12. Divide both sides by 10. T equals 12/10 or 6/5. So it appears I have the solution negative 3/5, 6/5. Okay. The only thing left is to now check it in the other equation. Now, I solved for t in the top equation, so I'm going to check it in the bottom equation. 2 times s plus t equals 0. Well, this is what? Negative 6/5 plus 6/5, 0 equals 0. So it checks. So if I were to graph these two equations, they would intersect at this point, which is the solution. All right, let's take a look at another problem. This is also from section 4.2. This is number 8. Same directions, solve the system by substitution if possible. If the system has no solution or infinitely many solutions, so state. And let's see, we have y equals negative x over 2 as our first equation, and 2x minus 3y equals negative 7 as our second equation. Okay, so let's label them again. Equation 1 and 2. I'm going to take equation 1 and solve it for y because it already is. So y equals negative x over 2. It's already solved for y, so step 1 is done. So now I'm going to substitute that in the place of y in the other original equation. So equation number 2. This gives me 2x minus 3 times y, but we're replacing y with negative x over 2 equals negative 7. This should produce one equation with one unknown, and it does. It produces an equation with just x. So step 3 is to solve this equation. So 2x, let's see, minus 3 times minus x would be plus 3x over 2 equals negative 7. Oh, let's see. We could clear the fractions or we could add them. Well, let's go ahead and clear the fractions. So we'll multiply both sides by 2. So I get 4x plus what? 3x equals negative 14, because the 2 times 2x is 4x. 2 times 3x over 2 would be 6x over 2, or 3x. Going on, 7x equals negative 14, and finally x equals negative 2. So we see from the end of step 3, this problem is just like the previous problem in that we have a variable equals a number. So we're going to go on and complete the ordered pair. All right. So step 4 is to take the results of step 3 and plug it into either one of the original equations. I'm going to plug it into equation number 1, the top one. So y equals negative, and then x is negative 2 over 2, which would be what? 1. So now I've got this proposed solution, negative 2, 1. I'm going to check it in the other equation, which is equation 2. 2x minus 3y equals negative 7. Minus 4 minus 3 equals negative 7. Negative 7 equals negative 7. And the solution checks. All right. This takes us to one more example from this student, 4.2, number 13. Again, solve the system by substitution. And if it's no solution, say so. If it's infinitely many, say so. If it's an ordered pair, say so. All right. So what we have here is 7x plus y equals negative 5 plus 6x minus y. That's our first equation. And we have 3x plus y equals 2y plus x minus 5. These equations have a lot more in them than the previous equations. So let's simplify things. Let's see here. Let's take the first equation and let's move things around and combine like terms to make it an easier thing to deal with. So let's see. How about if we put the variables on the left and the constant on the right? So I'm going to subtract 6x from both sides. That will give me x plus y equals -5 minus y. Tell you what, I'm going to get rid of equation 2 and we'll come back to it in just a minute when we have more room. Let's see, then I'm going to add y to both sides. Actually, you know what? Wait a minute, not going to do that. Why not? Because now I've got x plus y equals -5 minus y. Ultimately, I want to solve one equation for one unknown. So how about if we do this? We subtract y from both sides, and now I have x equals -5 minus 2y. So equation 1 has been simplified, combining like terms and stuff, and solved for one of the variables, okay? So here, I'm going to call that our equation 1 now. Let me double check my work. Did I copy the problem correctly? Yes. Subtracting 6x from both sides. These would cancel. Subtracting y from both sides. Those would cancel. Okay, so there's equation 1. Now let's take a look at equation 2. Let's see, equation 2 is 3x plus y equals 2y plus x minus 5. Okay. Now, I could just go ahead and use that equation as it is and plug x in all the different places, but I think I want to simplify things a little bit more. I'm going to put all the variables on one side and a constant on the other. So let's see, I'm going to subtract 2y from both sides, and I'm going to subtract x from both sides. So I'm going to get what? 2x minus y equals -5. Okay, the 2y and the minus x. Okay, so that's going to be my equation 2. All right, so it's almost like I'm starting the problem over now that I've simplified the 2 equations. My first equation has been solved for x. So I'm going to take the fact that x equals all of that and put it in here in the other equation. So now I get 2 times x, but x has been replaced with -5 minus 2y, and then minus y equals -5. So after all that, I'm at step 3. I have one equation with one unknown. So let's see, we've got -10 minus 4y minus y equals -5. Combining like terms, -5y minus 10 equals -5. I'm going to add 10 to both sides of the equation. -5y equals +y. I'm going to divide both sides by -5y equals -1. So once again, I'm going to get a single point of a solution because at the end of this step, I got a variable equals a constant. I'm going to take that and plug it into either one of my original equations, and I'm going to call these 2 that are still left my original equations, okay? So if y is -1, I'll put it into equation 1 here. X equals -5 minus 2 times -1. X equals -5 plus 2. X equals -3. So it looks as though my solution is -3, -1. Now, I plug this into this equation. Let's check it in this equation. 2 times x minus y equals -5, -6 plus 1 equals -5, -5 equals -5, and it checks. All right, I've got a couple more questions that were asked from students. In fact, they're the same questions, but a different student. So I don't know, we'll see. I'll check to make sure they're not just the exact same numbers. Let's see here. Okay. Okay, let's see. No, it's different. Similar, but a couple of different numbers. All right, so this again is from section 4.2. This is number 7, but a different version from the one I did earlier, slightly different. Again, we're going to use substitution. The first equation is 5s plus 10t equals 6. The second equation is 2s. Oops, that didn't change colors like I wanted it to. Hang on here. There we go. All right. 2s plus t equals 0. And we'll call this equation 1 and equation 2. I'm going to go ahead and solve equation 2 for t because it's the easiest move. I'm going to subtract 2s from both sides. So t equals negative 2s. I've solved one of the equations for one of the unknowns. I'm going to take the result and replace t in the other equation. This gives me 5s plus 10 times t, but 10 is now, or excuse me, t is being substituted with negative 2s equals 6. So 5s minus 20s equals 6. Negative 15s equals 6. Divide by negative 15, s equals negative 3/5. Let's try that again. How about negative 2/5? Because we would reduce the top, let's see here, the top by 3 and the bottom by 3, we get negative 2/5. My bad, sorry about that. Okay, so once again, we've got a single solution. S is negative 2/5. I'm going to plug that into either one of the original equations. I'll plug it into the top equation, and we've got 5. My board is having issues. Let's see here. There we go. I'm not sure what's going on, but I'll just live with it. So 5s plus 10t equals 6. All right. That would reduce down to negative 2 plus 10t equals 6. Add 2 to both sides. 10t equals 8. Divide by 10, t equals 4/5. So my solution, negative 2/5, comma 4/5. Make sure that you list your ordered pairs in alphabetical order. And let's see, I found that in the top equation, so I'm going to check it in the bottom equation. Let's see here. 2s, so 2 times, hang on. 2 times s, and s is negative 2/5, plus 4/5 equals 0. Negative 4/5 plus 4/5 equals 0, so it checks. All right, one more. And this is another version of number 13. At least I think it is. Let me double check here. Let's see. Yeah, it's different. Okay. All right. It says solve a system by substitution again. And we've got 4x plus y equals negative 10 plus 3x minus y. Once again, I'm going to clean this equation up. I'm going to move everything over to the left side of the equation, the variables that is, and I'll leave the constant on the right. So I'm going to subtract 3x from both sides of the equation and add y to both sides of the equation. That gives me x plus 2y equals negative 10. Okay. I'm going to go ahead and subtract 2y from both sides. So I get x equals negative 2y minus 10. And that's going to be my cleaned up version of equation number 1. And let's take a look at equation number 2, which is 3x plus y equals 2y plus x minus 5. Again, I'm going to put everything on the left side of the equation. That is the variables and the constant on the right. So I'm going to subtract 2y from both sides and subtract x from both sides. And that gives me what? 2x minus y equals -5. Okay. So we've got 2x minus y equals -5. That's going to be our equation number 2. Okay, well, equation number 1 is already solved for one of the variables, x. So I'm going to take this and replace x in the other equation, right? So I get 2 times the quantity -2y minus 10 minus y equals -5, which is -4y minus 20 minus y is -5. Combining like terms, -5y minus 20 is -5. Add 20 to both sides, -5y equals 15. I'm going to take -5y equals 15 and divide both sides by -5, y equals -3. So once again, we're going to get a single point solution. All right, let's see. Y equals -3. Let's plug that into equation number 1. X equals -2 times -3 minus 10. X equals 6 minus 10, which is -4. So I've got -4 comma -3, but I'm going to check that in the other original equation. So 2 times x minus y equals -5. -8 plus 3 equals -5. -5 equals -5. It checks. So there's my solution, -4, -3. All right. And that takes us to section 4.3. Now, we've been looking at solving a system using substitution. And in substitution, we solve one of the equations for one of the variables, then we substitute it into the other equation, which gives us one equation with one unknown. From there, we solve the equation. We conclude which type of solution it is. If it's a single point, we go on and find both coordinates. In this new method, which is called elimination, it's also referred to as the addition method. So it's the elimination or addition method. I guess it would help if I wrote in such a way that you could actually read it. Elimination or addition method. The goal is the same, to solve the system of equations. Steps 3, 4, and 5 are the same as substitution. Steps 1 and 2 lead to how we get the one equation with one unknown. Once we've got that, step 3, 4, and 5, we solve the equation for the unknown, plug it into one equation, get the result, check it in the other equation. But how we get to that one equation with one unknown is different in the elimination or addition method. What I want to do, first of all, is to justify the steps I'm going to do. And that is to say, let's say I have an equation, 2x plus y equals 7. It says 2x plus y equals 7. So that means that 2x plus y and 7 are equal quantities. Let's say I had another equation that was x minus y equals 4. Okay, so x minus y is equal to 4. Now, we can add the same quantity to both sides of an equation and get a new equivalent equation that still has the same solution set. So what if I took this equation and I added the same quantity to both sides? Okay, that would be legal. But isn't x minus y equal to 4? So I could add x minus y to one side of the equation and add 4 to the other side of that equation up top, and that would be legal because x minus y is the same thing as 4. So basically what I'm going to do is this. I'm going to add these two equations together. Now look what happened when I did that. The y's canceled. So I ended up getting one equation with one unknown. And from there, I could go on and solve and say, oh, x is 11/3. And I could go back and plug it into one of the equations and get the result for y and check it in the other one. And we'll be doing that eventually. But again, I just wanted to justify why I can add the equations together. Okay. So now let's take a look at an example. All right. We have x plus y equals 5. That's one of our equations. And x minus y equals 1. Oh, you know what? I want to go back for a minute. Why did the y's cancel in my example? Because their coefficients were opposites, right? Positive 1y plus a negative 1y. The y's canceled out and gave us 0y. Well, in this system, it's already set up that way. If we add the two equations together, we get 2x equals 6, because a plus 1y and a minus 1y is 0y. So we've basically eliminated one of the variables by adding the two equations. That's where we get the name of elimination or addition method. Okay, so now I have one equation with one unknown. Going on from there, solve the equation for the unknown, check it into one of the original equations. I'll put it into the top equation. So I get 3, 2, whoops. Check it in the bottom equation. And it checks. Now you might be saying, wow, that was a lot quicker than the substitution method. Why wouldn't you want to just use this method all the time? Well, here's the thing. These two original equations were already nice in that by just adding them together, we were able to eliminate one of the variables. They're not always that nice. Sometimes we have to do some extra work to get them where we want them. And let's see here, trying to find one that's going to require some extra work. Here's one. Okay, we're going to jump right into the fire here. This says 5x minus 14y minus 32 equals 0. The second equation, negative x equals 6y plus 20. Okay, now, ultimately, I'm going to be adding the two equations together. So what I want to do is I want to line things up so that the x's are in the same place, the same column, the y's are in the same column, the constants are in the same column, so that when I add them together, I'm not having to, try and add things that aren't in the same vertical column. What I'm going to do, I'm going to take this top equation and I'm going to add 32 to both sides of the equation. So that's going to give me this, 5x minus 14y equals 32. Okay. I'm going to take the bottom equation and I'm going to subtract 6y from both sides. And that's going to give me, let's see, what is that going to give me? Negative x minus 6y equals 20. Okay. So what have I accomplished? I've got my x's lined up, my y's lined up, and my constants lined up. But I have another problem. For one of the variables to cancel out, I have to have, like, for instance, this and this would have to have opposite coefficients. If it was 5x and minus 5x, and I added them together, the x's would cancel. Or if I wanted to get rid of the y's, negative 14y, negative 6y, I would have to manipulate both equations to where the coefficients were opposites. So like I need to find the least common multiple of 14 and 6, which, wow, it's like 42. So I'd have to multiply the top to turn it into a 42y and the bottom to turn it into a 42y or a negative 42y. So it seems to me like it would be less work to deal with the x's. Okay, so what I can do is this. I'm going to leave, let's see, I'm going to leave equation 1 just like it is. 5x minus 14y equals 32. Okay. I'm going to take equation number 2 and I'm going to multiply both sides of it by 5. Why did I choose a 5? Because now I get negative 5x minus 30y equals 100. So by multiplying both sides of equation number 2 by 5, the new coefficient of x is negative 5. Why is that a good thing? That's a good thing because now when I come in, whoops, okay. I accidentally moved something, so now I got to fix it here. Sorry about that. Okay. When I add these two equations together, what am I going to get? The x's are going to cancel, and I'm going to get negative 44y equals 132. You see how that happened? So that was a lot more work than that previous example, wasn't it? So maybe elimination isn't better than substitution. It kind of depends on what your original equations look like. But so now I have one equation with one unknown. But again, what did I do? I manipulated the second equation so that my coefficients of x were opposites, so that when I added them together, they canceled. So now I'm going to solve the one equation. Oops. For the one unknown, would help if I divided both sides by the same number. Here we go. Let's try this again. Divide by negative 44, divide by negative 44, y equals negative 3. Okay, so y equals negative 3. That means that once again, we've got a system with one solution. So now I've got to check it in both of my original equations. I'll plug it into equation number 1 right there. So I get 5x minus 14 times negative 3 equals 32. 5x plus 52 equals 32. Subtract 52 from both sides. 5x equals negative 20. Divide by 5, x equals negative 4. Let's see here. Messed up, didn't I? Yep, sure did. My multiplication's not what it used to be, apparently. This would be what? Plus 42. Aha. Then we'd minus 42 from both sides. 5x equals negative 10. Divide by 5x equals negative 2. So easy to mess up. Now, if I'd kept going, I would have found that it didn't work, but I didn't want to waste your time with that. Okay, so we've got negative 2, negative 3, and we found it in the equation 1. Now let's check it in equation 2. Negative 5 times negative 2 minus 30 times negative 2 equals 100. It's not working. So what have I done wrong? Let's see. Negative 5x minus 30 y. Oh, I see what I did wrong. Yeah, there I go. But I knew there was a mistake because it wasn't going to check. I wasn't going to get 100 equals 100. 10 plus 90 equals 100. So one of the nice things is that when you make mistakes, often as you continue on and check your work, you'll find the mistake, or you'll find that it doesn't work and you can go back. All right, now, I want to do a problem. I haven't done any today where the answer was no solution or infinitely many solutions. So I want to do a couple examples of this where that is the case. Let's see here. Let's do this one. 2 times the quantity x plus 2y equals 15, and 3x equals 8 minus 6y. All right, so we've got equation 1, equation 2. So once again, I'm going to distribute and get things lined up. So I've got my something x's plus something y's equals a constant. Okay, so for that top equation, distributing, I get 2x plus 4y equals 15. So 2x plus 4y equals 15. Okay. The second equation, I'm going to add 6y to both sides. So I get 3x plus 6y equals 8. Okay. Now, so there's my equations in a nicer form. I've got my x column lined up, my y column lined up, my constant column lined up. I need to get rid of the x's or I need to get rid of the y's. Neither one of them are going to just automatically happen. As it turns out, I'm going to have to manipulate both equations. Let's consider x, okay? I've got 2x on top and 3x on the bottom. What's the least common multiple of 2 and 3? 6. So what if I took the first equation and multiplied both sides by 3? Okay, that's going to give me 6x plus 12y equals 45. Okay. I'm going to take the second equation and I'm going to multiply it both sides by -2. Why -2? Because -2 times 3x is going to give me -6x. And ultimately, when I add the two equations together, the x's are going to cancel. Minus 12y equals -16. Okay, so far so good? All right, so now, and again, I was focusing on getting rid of x's. 6x minus 6x is 0. Oh, look at that, 12y minus 12y is 0. So in this case, both of them cancel. 45 minus 16 is what, 29? So I get 0 equals 29. That's a false statement, so there's no solution. Again, in my attempt to get one equation with one unknown, I got no solution. I got a statement that's false. Okay. All right, let's take a look at another one. Let's see here. How much time? I've got 12 minutes. Okay. I'm going to do one that's going to take a while, but it just kind of shows how awful things can get. Just what you wanted to hear. This one's got a bunch of fractions in it, so we'll deal with that. We've got 1/5 x plus 3/5 y equals 4/5. That's our first equation. Okay. I'm going to multiply both sides by 5. 5 times 1/5 is 1 times x is x. 5 times 3/5 is 15/5 is 3 times y. 4/5 times 5 is 4. Okay, so I took the first equation and I cleared the fractions. The second equation, this thing keeps freezing up on me. Let's see, where did it go? Second equation is 1/6 x plus 1/2 y equals 2/3. Here, the least common denominator is 6. 6 times 1/6 x would be 6/6 or 1x or just x, plus 6 times 1/2 would be 3y equals 12/3, which is 4. Interesting. So by clearing the fractions, notice these two equations look the same. So if I want to, let's see, let's put this equation here, okay? What would I have to do so that when I add them, the x's would cancel? I'd have to have the coefficient of x on top, a 1, and the coefficient of x on the bottom, a -1. So let's do this. Let's go back here, and let's multiply both sides by -1. So then I've got -x minus 3y equals -4. Now when I go to add them up, what do I get? Oh, I get 0 equals 0. Is that a true statement? Yes. So there are infinitely many solutions. Okay. So to cancel out a variable, the coefficients have to be opposites. In this case, when I worked on canceling out x, it also canceled out y because they were the same equation. That doesn't always happen, as we see back here, okay? Or let's see. Here, we got rid of the x's, but we didn't get rid of the y's. All right. So for tonight, you've got section 4.3, the elimination or addition method. Just be careful when you're clearing fractions and decimals, double check your work. Oftentimes a little mistake. You saw me make a couple little mistakes, and it's all it takes is one little mistake, and then everything after that is a mess. So be careful with that. I'll be back at 1:15 today with an office hour. Anyway, that's all for now. Bye.